Good evening to all of you. Welcome you guys. Welcome you all. Very good evening to everybody. Do join the session fastly, all of you. Right. We are live. Yeah. First of all, you tell me now. Do comment करके बोलिए. So is the audio video is clear to everybody? बोलिए जल्दी. Audio video is clear to everybody. Do comment करके बोलिए. चलो. So you can get. So there is a chance to get flat 60% of discount for all GATE and Academy subscription. That is just 9,999 only. 9,999 only. So we are starting the GATE set go for 2026 के लिए मेगा बूट कैंप हमने शुरू किया. We are going to discuss each educators will take one specific topic and they will discuss the topic very in detailed manner will be covered. I have going to discuss the transients in the networks. From the basics to advanced level, we are going to discuss. And the classes which will be held in the YouTube as well as special class. And today and tomorrow we'll have a class on YouTube. And another remaining two classes are the special class. The continuation of these two classes will happen. And the student who has participated in the test, they can able to get Amazon voucher worth 3,000 rupees they can able to get. And utilize this opportunity. Everybody do utilize this opportunity. And we started a Udaan batch हमने शुरू किया ISRO के लिए. You can do subscribe for this using a code of BV Reddy. The network is started at 7 p.m. We are going to start the from June 27th onward नया बैच भी शुरू होने वाला गेट एंड ESC के लिए. The batch is starting from 2027 जून से शुरू होने वाला. We are starting with the networks. I am going to start at 9 p.m. EC and electrical दोनों के लिए. And this ATC batch also we started. That is the subscription just 3,999 only. You can use the code of BVReady and to get this great offer. And we are providing the scholarship test. That is the test series is very important as you know for the evaluation purpose. जितना भी आपने सीखा बट अगर टेस्ट नहीं किया तो कोई फायदा नहीं है. सो हियर हमारा अल्टीमेट प्रिपरेशन गेट की तैयारी करना. सो ये टेस्ट सीरीज से आपको पूरा पता चलेगा टेस्ट सीरीज कैसा होगा. You will get to know how the real gate exam with the test series what we have designed. The test series which is designed by the top educators team, and we are planning the topic wise test, subject wise test, advanced subject, multi subjects, full length PYQs test. Totally we have 77 test series test. And totally how many questions are there? You can see 2645 questions are there. The test series which is live from April 1st onwards. Which is live from April 1st onwards. And we do offer there two type of subscriptions. One is a plus, the other one is iconic. And plus में आपको क्या मिलेगा? You can see ना plus में आपको top educators का classes you can do watch, live doubts, structured courses, live quiz, unlimited access. iconic में इसके साथ आपको बढ़िया बढ़िया से ऑफर मिलेगा. That is a personal coach भी मिलेगा, physical notes भी आपको मिलेगा. right? You can book the slot, directly interact with the educators. So let's plan your Unacademy subscription. These are the GATE 2025 rankers from Unacademy. Yes, चलो आज का सेशन हम शुरू करेगा. Yeah, Rishi, I do inform. I will confirm it. So here, if there is anything issues are there, I will confirm it. Okay, I will. I will discuss with the team. I will confirm it. ठीक है. चलो, transient. तो सबसे पहले बोलिए ना transient क्या है? What is when the transient? You tell me. Transient क्या है? Tell me. तो ये सोचिए आपको ये आपका ट्रांसेंट के बारे में आपको क्या क्या पता? यू टेल मी. ट्रांसेंट का मतलब इज व्हाट? टेल मी नाउ हियर. Some unexpected things. What is the things, sir? Some unexpected. It may be good or bad. If there's something was happen in your आपका लाइफ में कुछ हुआ तो whether that may be a good manner, may be bad manner, कोई भी हो कुछ हुआ, either whether it may be a good or bad, because yes, then we cannot accept the sudden things immediately. Sudden things immediately we cannot accept it. Right. Yeah, this course. And this in this I'm discussing the only the transient part. I will cover completely detailed manner. Okay. So in your life, if something was happened unexpectedly, something was happened, whether it may be a good, maybe a bad, then we cannot accept the scenario immediately. We cannot take that scenario. We cannot accept it. So because of that, what happens? You tell me now here, we become some excited manner, some depression manner, isn't it? Exactly same thing will happen for the system also. Yes, Ashish, you think about this thing here. For example, so here in आपका गेट 2026 में आपको AIR 1 मिला. You heard the news. So Ashish got the AIR 1 rank. The moment you heard the news, आपको क्या message होगा? How you feel about the instant? I'm asking. The moment you heard the news, how you feel? आपको ज़्यादा excitement होगा, isn't it? Yes, then ज़्यादा excitement होके so then आप नाचेगा, आप mad बनेगा. The instant you heard the news, isn't it? That scenario is called as a transient. Like this, that's what we used to say. It may be a good manner, maybe bad manner. Whatever the things that happen in your career, in your life, we cannot accept them suddenly. Yes. So the same thing here, the system also, what a system in the sense that the networks containing the memory element, that is inductors and capacitors. Inductors and capacitor also does not accept the sudden things. Means what happens? So for example, when you start giving a supply to the inductor, some circuit you are giving, suddenly आपने supply को stop किया, बंद किया, it does not digest. The inductor does not accept these things, sudden things. Yes, this property we used to call the physics sense, we used to call it inertia. The physics sense will call this as what an inertia we used to call. Exactly same thing, capacitance also. If something was happened, a capacitor also does not accept, isn't it? So those mechanisms we are going to discuss in detailed manner after session में. So transient, when we have, you tell me now here, transients. The transient का reason क्या है? Tell me now. Transients will occur in the circuit if the network, due to the presence of energy storing elements, what are energy storing elements, you tell me? Inductors and capacitors. अगर inductors capacitor हुआ तो then those cannot accept the sudden things. अगर in the network contains केवल resistors है तो we don't have any transient. Transient does not occur. If the network contains only resistors, then we don't have any transient. Why? Because resistor is a memoryless element. It cannot store any energy. Inductor stores the energy in the form of magnetic field. Capacitor stores in the form of electric field. So because of that only we have transient will occur. And compared to, so here DC transients are very dangerous compared to AC transients. DC are very dangerous compared to AC. When we have a transient can happen in the network under three conditions. First, सबसे बढ़िया condition, the network should contain at least one energy delivering source. At least one energy delivering source. Which will deliver energy, you tell me? Which will deliver energy? Only the independent sources can able to deliver energy. So that's why we should have at least one independent source must present. And the network should contain at least one memory element. Memory elements are what? Inductor, capacitors. It should contain either inductor should present, capacitor should present, or both present. It should contain either inductor or capacitor or both. Okay. And there should be a switching action. Switching action means what? On to off, off to on. कुछ भी हो. Either on से off or off से on. Anything. So then that will causes the transients. ठीक है. Now you see the transient mechanism का बारे में. Point 3, DC transient. So you will get, so DC transient you will get to know more clarity about this thing here. When I'm discussing the AC transient, then what happens now? In case of a AC transient, it is possible to eliminate the transients. But DC transients are not at all possible to eliminate. So how the AC supply you can see? How we have AC supply? If I say this is my AC supply, this is the AC supply. Look at now here at this location, you see this thing at these points. So what is the supply you tell me now at these locations when I touch the x-axis? What is the supply you tell me now? Completely zero. If I can able to disturb, if I can able to do anything, if I can able to do any disturbance in the circuit at this instant of time exactly, if I can able to do the disturbance only at that locations, then in that scenario we don't have any transit. Why? Because at that location what happens now here, what is the condition for the transient to occur? Should have an independent source must be there now. At least one source, one energy delivering source must be present. But at this instant, there is no energy delivering source. Now you tell me at that instant. At that instant, we don't have any transient. If I did any disturbance, अगर मैंने मेरा disturbance exactly ये time पर मैंने disturb किया, disturbance in the sense whether on या off, as or if you have taken some element you removed, or you have added some element, that is called as a disturbance. If you did any disturbance at these points are called as zero crossing points. These are called as zero crossings. These are called as what I'll mean of zero crossing. If I did the disturbance, any disturbance with zero crossings, then the transients are eliminated. That's why. But DC transient is not possible to eliminate. समझ में आया this thing? Right. Let's see the transient mechanism. Yes, transient mechanism. Look at now here. सुनिए ध्यान से सुनिए. सो हियर इसमें आपको पूरा ट्रांसेंट का मैकेनिज्म समझ में आएगा. Look at now here. This is the in time we used to call this as what element of t equal to 0 minus. इसका t is equal to 0 minus. What is the t is equal to 0? We did some disturbance. We did disturbance का मतलब is what element here. So on, off, add element, remove element. कुछ भी करो in the circuit में. If you did anything in the circuit, then that is called as a disturbance. At t is equal to 0, मैंने कुछ disturbance किया. And t is equal to 0 minus, which is called as the disturbance time, which we call it as switching action. And t is equal to 0 minus. Well, t is equal to 0 minus is that is what is just before switching action. T is equal to 0 minus is what I mean. Just before switching action. Just before switching action, क्या होगा? You tell me. Just before switching action, I didn't do any disturbance. मैंने कुछ disturbance नहीं किया. And t is equal to 0 plus. Immediately after very small time, t is equal to 0 plus, which is called as what? Tell me. Just after switching action. T is equal to 0 plus means what? Just after switching action. And t turns to infinity, which is means what? Tell me now. A long time. A long time after switching action. A long time after switching action. मैंने बोला ना. So here अगर आपने कुछ न्यूज़ सुना, we heard something. It may be good news, maybe bad news. The moment you heard that news, then आपको ज्यादा excitement होगा, isn't it? आपको ज्यादा excitement बनेगा. But so here, yes, कुछ टाइम के बाद, it may be depends upon the person to person. So it may be take the 1 hour, 1 day, 1 year. कुछ टाइम के बाद क्या होगा? You tell me. Yes, you doesn't feel anything about that news what you heard. Okay, समझ में आया? So अगर सिंपली ध्यान दो हियर. So अगर आपने आपका जस्ट मान लो आपका फेवरेट हीरोइन ने आपके पास आके आपको प्रपोज किया. फेवरेट एक्ट्रेस ने आपको प्रपोज किया. आपको कैसा लगेगा? यू टेल मी. कैसा लगेगा? कैसा महसूस होगा? यू टेल मी नाउ. यू विल गेट सो मच एक्साइटमेंट. ना बोल. वो एक्साइटमेंट कुछ देर तक चलेगा. सम टाइम इट विल बी कंटिन्यू. And after some time, so it doesn't feel any new things. Some other way, कुछ दिन के बाद, so here, so आपका ब्रेकअप बोला. क्या होगा? You tell me now. Again you will get depressed ना. Again you will get depressed. अगर वो टाइम में आपको अच्छा से हैंडल नहीं किया तो आप तो पागल बनेगा. Isn't it? You will get a lot of disturbed from your career. अगर अच्छा से संभाल ना किया तो. Isn't it? That scenario, that means what? Excitement state, over excitement, depression, that is a transient. And comfortable state. So here comfortable state, normal state, that is called a steady state. आपको कुछ समझ में आ रहा कि नहीं बोल, ट्रांसिएंट स्टेट के बारे में अभी बोल। कुछ समझ में आ रहा कि नहीं बोल, ट्रांसिएंट स्टेट का मतलब क्या है, आपको समझ में आया? बोलो यार, कभी तो हाँ ना बोल। राइट, यस। द ट्रांसिएंट स्टेट का मतलब क्या है? टेल मी नाउ हियर। Any disturbance, the disturbance scenario is called as a transient state, and comfortable state, happy state. So here, wait. So here that is called as a steady state. And let's talk about the some basic parameters. Current passing through inductor. What is the current passing through inductor? You tell me. Expressions we'll see first. And so basically, what is the voltage across inductor? You tell me. VL of t, which is given as L into T IL of t by dt, isn't it? Yeah, from this we can get it as IL of t will come, that is 1 by L into integral, limits are way to way from minus infinite to present time. Why? Because inductor is what type of element? Is a energy storing element. We need to see the past behavior also, we need to see. Then IL of t, which we can split it as what will be now 1 by L integral from minus infinite to 0. This I am calling this as 0 minus. 0 minus, that is VL of t into dt plus 1 by L into integral of 0 minus to present time VL of t into dt. And this term, what we can say, you tell me now here, this is IL of t, which is equal to 1 by L. This first term, what we can say now, this is the current passing through the inductor before switching action, isn't it? This is the current. This current, which we used to call it as initial current. This current is called as what? Tell me, initial current. This current will denote as IL of 0 minus. Current through the inductor before switching action. Okay. Plus, that is 1 by L integral of what we can say now 0 minus to t and VL of t into dt. Okay. This is my IL of t. So here, where what is this thing? IL of 0 minus, which is called as what? Initial current. Initial current. Yes, from this, you see this thing here. This terms we can see now, this IL of T is a current, this is initial current, this also initial current. From this, we can form for this equation 1, if I say, for this equation 1, we can able to form a circuit now. So this circuit, now I can say this is nothing but what we can say now KCL equation now. And what the KCL equation is? Sum of entry currents equal to sum of leaving currents, I can say. Yeah, you can tell me now here. Sum of entry currents, which is equal to sum of leaving currents. Right, so this current, this is inductor. it has some initial current. This initial current is what I know IL of 0 minus, and here is an inductor. This current which is equal to IL of t, and here this voltage which is VL of t. So you can see now here by applying the KCL at this node, we can get the relation now here. This equation will come. So sum of entry currents at this node equal to sum of leaving current. So this is the equivalent circuit of inductor. So means what we can say inductor, equivalent circuit of inductor means what we can say inductor always have a parallel initial current. Inductor will have a shunt initial current. So this thing, or we can redraw this part as some other manner. What we can draw it, you may draw it as like this also. Like this. Now this is initial value, this is IL of 0 minus, and this is IL of t, and this voltage which is VL of t. समझ में आया? Inductor equivalent circuit, whenever you say inductor, equivalent circuit of inductor is what? Tell me. It always have a parallel initial current, shunt initial current, inductor equivalent circuit. That is what I mean of shunt initial current. Then next, now see this thing here, the nature we can talk now here. The equation what we got, that is IL of t. समझ में आया ना सभी को बोल? Which is equal to what we can say now here, IL of 0 minus plus 1 by L integral of what we can say here 0 minus to t into VL of t into dt. Okay, this is the equivalent circuit of a equivalent equation for the inductor. Now, if we talk about this thing, this is for inductor. Similarly, we'll talk about for capacitor. Right. So you see this thing here. Let's see then how the inductor will behave at t is equal to 0 minus. Now, if you see the equivalent circuit of inductor is what terminal of inductor will have a parallel initial current. And this is IL of 0 minus the inductor. This is VL of t, and this is IL of t. Okay. Now you see this thing here at t is equal to 0. At t is equal to 0 plus. I want to find out this value. Now put the t is equal to 0 plus in the above equation. Then IL of 0 plus, which is equal to what? Tell me. IL of 0 minus plus 1 by L integral of 0 minus to 0 plus into VL of t into dt. Na? So that means they are saying the integration of a some curve from way to way to tell me now within a zero time. So this is they're talking about the 0 minus to 0 plus time only, na 0 minus, and here we have 0 plus. And practically we don't have any signal which can rise from the 0 minus to 0 plus. So as a result, this term will become what you tell me now, 0. Okay. So from this, what we can say, you tell me now here from this. Yes, that is IL of 0 plus, which is equal to what you tell me now, IL of 0 minus IL of 0 plus equal to IL of 0 minus. What is the IL of 0 plus is a current through the inductor just before switching action equal to current through inductor just after switching action. Okay. Yeah, seriously. IL of 0 minus is equal to IL of 0 plus. इसका मतलब is what, tell me? Inductor does not allow sudden changes of current. Inductor does not allow sudden changes of current. And the current through this inductor is what, tell me now, which is a continuous function. It cannot be discontinuous function. IL of 0 minus equal to IL of 0 plus is equal to, simply we can say IL of 0. As we know, this is a left limit now here. 0 minus means this is a right limit. Left limit equal to right limit. Then we can say the function is a continuous function, we can say now. So that's why inductor does not allow sudden changes of current. ठीक है? Next. Now let's talk about the voltage across capacitor के बारे में. Yes. Now tell me what is the current through the capacitor. You tell me first of all. I. I equal to what we can say now, C into dVc of t by dt. I equal to C into dV by dt. And what is the voltage now? You tell me now, Vc of t, which will becomes as what, tell me now, 1 by C integral from minus infinite to t, that is Ic of t into dt. Then what we can say now here, Vc of t is equal to 1 by C integral from minus infinite to 0 minus and Ic of t into dt plus 1 by C. We can split the limits now, 0 minus to t, and this is Ic of t into dt. Right. Now the first term, what we can say now, this term, this is nothing but this is the voltage across the capacitor just before switching action. So this, which we can say this as what, tell me now here, Vc of t is equal to what we can say, tell me now here, Vc of 0 minus plus 1 by C 0 minus to t. This is Ic of t into dt. Isn't it? And what the Vc of 0 minus, which is called as the initial voltage. This is called as the initial voltage. Right. Now we can see now here we got this equation. So I can say this is nothing but simply one KVL equation. Now tell me. So KVL equation के लिए equation we can develop the circuit. Tell me now how the circuit we can develop it. And here we have some voltage source. And here is a capacitor. Okay. You can see if we apply the KVL in this loop, you can get this equation. मिलेगा हमको चेक करके बोलिए. We'll get this equation now. Yes. So this is the equivalent circuit of capacitor. So here VC of 0 minus is the initial value. So how we can say now here capacitor will have a series initial voltage. Tell me now what we can say. Capacitor will have series initial voltage. Capacitor will have series initial voltage. Inductor has a parallel initial current. Capacitor has series initial voltage. Now you can tell me now here we got the relations, we got it. So that is what we can say here. VC of t, which is equal to what we can say VC of 0 minus plus 1 by C integral of 0 minus to t. I can say this as IC of t into dt. I can say now. Tell me. Now we are going to analyze at t is equal to 0 plus. Tell me what happens. Means VC of 0 plus, which is equal to what? Tell me now. VC of 0 minus plus 1 by C and 0 minus to 0 plus and IC of t into dt बनेगा. Now you see this thing, integration of function from way to way 0 minus to 0 plus, which is 0. So from this VC of 0 plus, which is equal to, we can say VC of 0 minus, we can say. Now tell me. What is the VC of 0 plus? Voltage across capacitor just after closing the switch. And VC of 0 minus is the voltage across capacitor just before equal to just after. Now for this what we can comment now here, capacitor does not allow sudden changes of voltage. Capacitor does not allow sudden changes of voltage, and voltage across capacitor is what we can say continuous function. VC of 0 minus equal to VC of 0 plus. ये बात समझ में आया? Done. Yes. ठीक है? Yes, ये पॉइंट हमेशा आपके दिमाग में होना. Inductor does not allow sudden changes of current. Capacitor does not allow sudden changes of voltage. Next, now let us talk about behavior of inductor at t is equal to 0 plus and at t is equal to infinity. And we'll talk at t is equal to 0 plus. What is t is equal to 0 plus? Basically, just after closing the switch. Just after closing the switch, which is called as what? Tell me now. Transient state. And just after closing the switch, which is called as a transient state. Now tell me, if we have redrawn the circuit, inductor will have a parallel initial current. Inductor equivalent circuit is what? Parallel initial current always. So this is IL of 0 minus. Here is L. This current which is equal to VL of t, and this current, this voltage, and this current VL of t, IL of t. Okay. Now here you see this thing here. We could talk about the circuit at t is equal to 0 plus. We have this equation. You can see now here there is some current. If I call this is something X, what we can say, tell me now, IL of t, which is equal to what? Tell me now, KCL we apply now, X plus what we can say, IL of 0 minus. Now at t is equal to 0 plus when you have taken. So see what happens. IL of 0 plus, which is equal to X plus something IL of 0 minus now. But we know that, what we know, inductor does not allow sudden changes of current. IL of 0 plus equal to IL of 0 minus होना पड़ेगा. इसका मतलब इस व्हाट टेल मी नाउ हियर. सो जो ये x है ना, ये x को 0 बनना पड़ेगा, तभी ये इक्वेशन को सैटिस्फाई करेगा ना. To satisfy this thing here, x must be equal to 0. And what the x you tell me now? X is nothing but what? The current passing through this inductor only na. So that means if x is equal to 0, the current through inductor is how much? 0. Huh? Current through inductor is 0. That means what we can say? If the current passing through any element is 0, then we can say that element is offering the very high impedance, that is infinite impedance. And I can say that inductor which is behaving like a open circuit, I can say. Inductor behaving like a open circuit, I can treat na. At t is equal to 0 plus. At t is equal to 0 plus, inductor behaving like what? Tell me, open circuit. समझ में आया ये बात? And if we talk about now here, t tending to infinity now. When you talk about t tends to infinity, and when you talk about t tends to infinity, you tell me now here, t tending to infinity. What is the t tends to infinity means? A long time after switching action. A long time after switching action, which we can call this as what? Tell me. That is nothing but steady state, we can say. That is a steady state, right? A long time after switching action, which is called as a steady state. Now you tell me now, yes, in steady state, the energy stored by the inductor, if we see, energy stored by inductor, which is equal to half into L into, yes, IL of t whole square. So that is the energy stored, which is what we can say now. This value reaches to a maximum value, maximum and constant, isn't it? Maximum value which is always constant only, एक ही value होगा. This value to be maximum means 1 by 2 always constant, L is also constant, but for this value to be remain constant, I can say that IL of t must be remain constant. This value has to reach to a maximum value, and that must be a constant होना पड़ेगा, तभी ये satisfy करेगा ना. And so if it is IL of t is a maximum and constant, so what is its derivative? You tell me now, dIL of t by dt. If I differentiate it, so we need to find this one IL VL. So VL of t we have to find. That is what we can say. Tell me, L into dIL of t by dt. Then this value IL of t is a constant, derivative of constant is 0. So I can say it as what tell me now IL of t, which will become 0 now. But sorry, VL of t 0. VL of t 0 means VL of t is what? Voltage across inductor. Voltage across inductor is 0. इसका मतलब is what tell me? इसका मतलब is what tell me? Inductor behaving like what we can say? Short circuit. Voltage 0 means we can say it is behaving like a short circuit, I can say. So that means inductor behaves like short circuit, and in where you tell me now in steady state, and in transient state it behaving like what tell me open circuit. This point clear to everybody? Now let's talk about the working of this capacitor also. Behavior of capacitor. Now, so the behavior of capacitor. Now, if we see this thing here, equivalent circuit of capacitor. And what the equivalent circuit of capacitor? Capacitor will always have a series initial voltage and this is Vc of 0 minus, and this is C. This is what I will know Vc of t, and this is Ic of t. Now if we apply KVL, we can get the equation, right? Yeah, you see this thing here. So the equation, if we see here, now if I call this voltage across this element is something X, if I call. If we simply apply KVL, tell me now what we'll get here. That is Vc of t, which is equal to what we can say now Vc of 0 minus plus what tell me now X banega. X banega. X is the initial value. Now if we see carefully, now here also we are talking at X is equal to t is equal to 0 plus. That means Vc of 0 plus, which is equal to what tell me Vc of 0 minus plus something X. Yes, but we know that we have seen ना अभी ने हमने देखा capacitor does not allow sudden changes of voltage. Vc of 0 plus must be equal to Vc of 0 minus होना पड़ेगा. To satisfy this thing, the condition is what we can say X must be 0 होना पड़ेगा. What the X is the voltage across this capacitor. Voltage across the element is 0. Then we can say that element is behaving like a short circuit. So from this we can say capacitor behave like what we can say, tell me now, short circuit. समझ में आया ना this point? Capacitor behaving like a short circuit at t is equal to 0 plus. ठीक है? Then now let's talk about the nature as when t tending to infinity also. When t tends to infinity, see what's going to happen, you tell me. Yes, when t tending to infinity, this is called as what I will now steady state na. A long time after switching action, which is called as what? Steady state. and we'll talk how the capacitor behaves in steady state में कैसा काम करेगा. Right. अभी देखो इधर. Now, so here, what is the energy stored by the capacitor? You tell me. That is of CV square. I can say that VC of T, VC of T whole square. Right. VC of T whole square. Now you see this thing here. This energy stored by the capacitor, which is a maximum, and this value, maximum value, is a constant or not? For this value to be constant, so क्या conditions होगा? You tell me now here. That means VC of T must be constant होना पड़ेगा. VC of T, it must be a maximum, and that value must be a constant, isn't it? Maximum and constant. This value maximum and constant hai to, then what is the current passing through capacitor? You tell me. I equal to C into dV by dt. Yes, so that means if I differentiate the constant, then the current will becomes what element of zero banega. That is, current passing through capacitor is how much? Zero. If the current is zero, iska matlab how the capacitor will behaving, you tell me. It is behaving like a open circuit, isn't it? Capacitor behaving like a open circuit in steady state. Now look at now here. In transient state, capacitor behave like a short circuit. In steady state, capacitor behave like a open circuit. Okay. Capacitor behave like a open circuit. Visible now here? Copy this thing, everybody tell me. Right. Clear this thing, everybody? Right. Look at now. The three songs of a transients. See this thing. The पूरा transient will depends upon it. तीन songs may depend होगा. You can have a look at. The first one is what I mean. IL of 0 minus equal IL of 0 plus. Inductor does not allow sudden changes of current. Repeat कर मेरे साथ. Repeat. Repeat कर मेरे साथ. So here. Chorus जैसा बनो. Prepare. Yes, repeat with me. Inductor does not allow sudden changes of current. Capacitor does not allow sudden changes of voltage. Inductor does not allow sudden changes of current. Capacitor does not allow sudden changes of voltage. Okay. And how the inductor will behave in transient state? Inductor behaves as open circuit. In steady state, inductor behaves like a short circuit. Capacitor in transient state behave like a short circuit, and steady state will behave like a open circuit. समझ में आ रहा कि नहीं बोल? सेकेंड सॉन्ग भी आपको, एंड तीसरा सॉन्ग दैट इज इंपॉर्टेंट हियर. द इक्वेशन फाइंडिंग के लिए तीसरा सॉन्ग भी यूज करेगा. And तीसरा song you tell me now here. IL of T, which is equal to what? Tell me. IL of T. IL of infinity plus IL of 0 minus. Or we can do, remember this as, so general function x of t, if we write the equation, that is given as what? Tell me general value. that is a final value plus initial value minus final value, initial value minus final value into e power minus t by tau. Final value plus initial value minus final value into e power minus t by tau. So this can be applicable for inductor or capacitor, both के लिए चलेगा, right? Inductor है तो tau which is given as what, tell me, L equivalent by R equivalent. And for capacitance I to, this is for the RL circuit. If it is a capacitive circuit, then which is given as R equivalent into C equivalent. This is for RC circuit. Okay. समझ में आया है ना everybody? If you have understood this thing, so all the transient problems you बनेगा. Transient में कुछ नया चीज सीखने वाले हैं ना, so there are 3 songs. ये 3 songs आपको स्मरण आया तो you can able to solve any transient problems. ठीक है? Then everybody, right? So what you do is the 3 songs आप अच्छा से सीख लो पहले. So कल same time we'll meet and we'll discuss the problems. Tomorrow we'll meet the same time. Tomorrow we'll discuss a variety of problems we are going to discuss in the tomorrow class. Fine, everybody? Yeah, that's it for today's session, and we'll meet tomorrow. In tomorrow, you will get to know more and more how to approach for the problem solving methods we are going to see. So we don't use any new things, only these things only we use again. केवल ये हम यूज करेगा, कुछ भी एक्स्ट्रा नहीं यूज करेगा. We don't use any new things, only these 3 songs only काम आएगा हमारा पूरा के लिए. ठीक है? Okay then, see you, bye bye.